All right, let's talk about one of the biggest data entry headaches in all of manufacturing. I'm going to show you how to solve it with a really powerful automated process that can, and I mean this, save you an incredible amount of time. So, does this sound familiar? Your team is spending hours and hours manually posting every single component, every minute of labor, every finished item. It's not just a massive time sink, it's practically an open invitation for mistakes. But what if you could make almost all of that just happen automatically? Well, you can. The solution is a concept called flushing. And honestly, it's a total game changer. You basically tell the system, hey, go ahead and automatically post my consumption and output for me based on what we planned to use. This right here is the secret to making your whole posting process ridiculously efficient. So here's our game plan. First, we'll cover the basics. What even is flushing? Then we'll get into the core mechanics, forward versus backward. After that, we'll look at some real-world scenarios, bust a few myths about using this with more advanced processes, and then wrap it all up with a smart strategy you can start thinking about today. Okay, let's dive in. At its heart, flushing is all about one thing: simplifying how you record what's actually happening on your shop floor. It's about taking that repetitive, manual work right off your plate. First things first, where do you actually set this stuff up? Well, for your materials, your components, you'll set the default flushing method on the item card or maybe the stock keeping unit card. For your labor and machine time, what we call operations, you'll set that on the work center or machine center card. Setting these defaults is huge because it means the system knows what to do without you having to tell it every single time. All right, this next part is maybe the most important concept to get your head around: the difference between forward and backward flushing. Seriously, once this clicks, everything else just falls into place. Think of it like this. Forward flushing is kind of like prepaying for your ingredients. The second you release that production order to the floor, the system immediately consumes the materials from inventory. They're gone. Backward flushing, on the other hand, is like settling your tab after the meal is over. The system just chills out, waits until you change the production order status to finished, and then bam, post everything all at once. And this timeline shows it perfectly. See? A forward flush happens right at the beginning, at the released stage. Then all the work gets done while it's in progress. And the backward flush, that gets triggered way at the end when you mark the order as finished. It's all about when that automation kicks in. Okay. Theory is great, but what does this actually look like in the real world? Let's walk through 3 super common setups that you'll probably see out on the shop floor. This table breaks it down nicely. Scenario A is the simplest. Everything is set to backward. You finish the job, you change the status, and the system handles the rest. Scenario B gets a little more detailed. You flush materials as you complete each step of the process. And Scenario C is a hybrid. You consume your materials up front, but you record your labor and output at the very end. So when do you use which? Well, Scenario A is your best friend for simple, straightforward production runs, where there are no surprises. Scenario B is perfect for those longer, multi-step processes where you need to track consumption along the way. And Scenario C? That's your go-to when you need to make sure those materials are pulled from inventory and reserved right at the start. And here's something you absolutely have to remember. You are never locked in. Even with all these great defaults, you can always jump into a specific production order and change the flushing method for one component or one operation. It gives you this incredible flexibility to handle exceptions. Okay, now we get to the part where people sometimes get stuck. They think, yeah, this sounds great for simple stuff, but my process is complicated. So let's tackle those concerns because flushing is way more powerful than you might think. This is the big one, right? The number one myth. Can you really trust an automated system when you're dealing with very specific lot numbers or serial numbers? I mean, the stakes are pretty high if the system grabs the wrong one. The answer is a huge, resounding yes. It works perfectly. There's just one simple golden rule you have to follow. You have to assign your tracking numbers before the system tries to do the flushing. You just tell the system which specific lots to use ahead of time, and it'll handle the rest. Let's just walk through it. Say you're using backward flushing. Step 1, when you release the order, you go in and assign the specific lot numbers. Step 2, you go do the actual production work. And step 3, when you finally change the status to finished, the system already knows exactly which lots to consume. The backward flush works flawlessly. It's really that straightforward. And you know what? Flushing also plays really nicely with advanced warehousing. If your facility uses warehouse picks, the process is super smooth. You pick the components from a stock bin, move them to a dedicated production bin, and the system knows to automatically flush the material from that specific bin. You'll even find special flushing methods just for this, like pick plus backward. So, we've covered the what, the how, and even the tricky cases. Now let's pull it all together. Let's talk about building a smart, practical strategy that gives you the best of both worlds. See, this is where it gets really powerful. The best strategy isn't all or nothing. It's about mixing and matching. Go ahead and automatically backflush all the cheap, common stuff, the nuts and bolts. But for your really expensive or critical components, set those to manual posting for tight control. Automate the cost for your simple, predictable machine operations, but manually track the actual time for the complex ones where you need that precise data. You now have all the building blocks to create a system that's perfectly tailored to how you work. The real magic here isn't just in using one method, it's in intelligently combining them. So I'll leave you with this. Take a hard look at your own processes and ask yourself, which of these tedious, time-wasting tasks can I finally automate?